Hello, pre-algebra. Welcome to another episode of Mr. Chow Time. Today we're talking about adding and subtracting integers. Well, integers. You remember what integers are? They're the whole numbers, 1, 2, 3, 4, 5, 6, 7, so on and so forth. They're opposites, -1, -2, -3, so on and so forth, and 0. So let's add and subtract these things. If we're adding integers with the same sign, for example, 1 and 3, or -2 and -5, then all we're doing is we're combining the distance on the number line, right? So when you're adding, we're taking this distance here, 1, and this distance here, 3, and we're putting them together, right? So that's 1, 2, 3, 4. Same thing with negative numbers. So -1, I'm not going to write -1. I'm only going to write -2 and -5. Here, we're -2 left of the number line, or net left of 0. And then 1, 2, 3, 4, 5, right? So we're going to put those together. We're moving to the left 2 times and then to the left 5 more times. That's -7. When we're adding integers with different signs, the signs, they kind of cancel each other out, right? Opposites destroy each other. So for example, 1 plus a -1 on the number line, we're adding 2 different directions, so they cancel each other out, and that equals 0. But if you're adding 2 things where one integer is bigger than the other in terms of the absolute value, then the one that's bigger wins, right? So if we had 2 plus -1, 2 is bigger, so we go to the right 2 times, and then we go to the left 1 time. So this is going to be 1. I think there's some more examples on the following page. There are -3 plus -4. So we're going to the left 3 times and to the left 4 more times. So basically this is just 3 plus 4. And because they're both negative, the answer just stays negative, -7. Here they're opposite, right? So 5 plus a -4, we've gone to the right 5 times and we go to the left 4 times. That leaves us with 1. This is the same thing as 5 minus 4. Here, again, we have 2 different signs. The easy way of doing it is 10 minus 6. That's 4. And which one wins? The 10 has the bigger absolute value. So the answer is -4. The additive inverse property, an integer and its opposite, the sum of any number and its opposite is 0. So if you have any 2 opposites and you add them together, then the answer is 0. Subtracting an integer is the same thing as adding its opposite. So just to illustrate that point, if I write 4 minus 3, this is the same thing as 4 plus a -3. That's what subtracting integers is. Yikes. Delete that. Moving on. So 4 plus -2, this is the same thing as 4 minus 2, right? 4 minus 2. And then we have another plus a negative, which is basically just another subtraction, right? 4 minus 2, I'm just going to do this over here. 4 minus 2 is 2. 2 minus 7. 2 minus 7, well, this is the same thing as 2 plus a -7, right? And because they're opposite, the one with the bigger absolute value wins. So we know that it's going to be negative. And then 7 minus 2 is 5. -5. Here we go again. Remember that with adding, even if you're adding negative numbers, you can commute them. You can move them around as you wish. So, oops, I didn't mean to delete all of that. We can commute these two and then commute these two. Okay, so 7 plus 12 is 19. And then we're going to add a negative 19 because negative 2 and negative 17 equals negative 19. So here we're adding opposites on a number line, which means that because of the additive inverse property, we have a 0. Here we have negative 8 plus 4 plus a negative 1 minus 6. So what can we do? Well, we can commute these two. So that's negative 8 plus a negative 1 plus 4 plus 6. So this is a 10 by substitution. This is a negative 9 by substitution. 10 plus a negative 9. 10 is the bigger number in terms of absolute value, so we know the answer is going to be positive. 10 minus 9 is 1. Positive 1. Inductive reasoning. This is the process of reaching a conclusion based on patterns. So let's look at this pattern here. If we're adding the inverse, so let's say we have a rule of 4 plus a negative x, and then we say that negative x is 2. So that's 4 plus negative 2. That's 2, right? Because 4 plus negative 2 is the same thing as 4 minus 2. The same thing as 4 minus 2. You get 2. So you see here, 4 plus negative x and 4 minus x, they give you the same answers. And from that, we can use inductive reasoning to see the pattern and to say as a conclusion that adding a negative is the same as subtracting. Does everyone see that? Adding a negative is the same thing as subtracting. Okay. So we're just going to do a couple more examples just to illustrate that point some more. Subtracting is the same thing as adding is opposite, right? So the opposite of negative 2 is 2. The opposite of negative 11 is 11. 11 minus 5 is 6. Which one wins? 11. That's the bigger absolute value. Another way to think about subtraction is the distance between two numbers on a number line. So, for example, 3 minus a negative 2. So we have 3 here, and we have negative 2 here. Remember, adding was adding the distances together, right? So 3 plus 2 is 3 plus 2. If we put those distances together, adding distances, then we get 5. But subtracting is the distance between two numbers. So, for example, 3 is over here, negative 2 is over here. What's the distance between these two numbers? 1, 2, 3, 4, 5. Right? Let's do it again. What about 3 minus 2? 3 is right here, 2 is right here. The distance between them is 1. Dang. So crazy. Remember when absolute value is a measure of distance on the number line, If I ask you to find the distance between 3 and -3 on the number line, you can represent that with the absolute value symbols. The difference of 3 and -3. We're finding a distance, so that's absolute value. One way that you can think about absolute value being distance and why that can never be negative is you can imagine yourself, and let's say you're facing this way, okay? If you were to walk forward 2 steps, that would be a distance of 2, right? And if you were to walk backwards 2 steps, would you be moving -2 steps? You know, let's say that each step is a foot. Would you be traveling 2 feet this way and -2 feet this way? No, you're not traveling -2 feet because there's no negative distances. A distance is always positive. No matter if you walk to the right or the left or forward or behind you, you're always moving some positive distance, right? And so that's what absolute value is. So if I ask you to find the distance between things, then you will represent that with the absolute value symbols. For example, the top of KAS is 78 feet above sea level. The bottom of the basement parking lot is 22 feet below sea level. What is the distance from the top to the bottom of the school? Write an expression to find the distance, then evaluate. So what's the distance? Here we're finding a distance, right? So we know to use the absolute value. Uh-oh. That was a mistake. Sorry about that. I can fix this. Here we go. Okay. You don't know what's going on in my house. I'm just talking and apologizing to you. It's just a voice. Okay. So we're finding the distance from the top to the bottom, right? Which means that if we were on a number line between one number and another number, we're not adding them together. We're not finding how much more. We're finding what is the distance between. So this is a subtraction problem, right? 78 is above sea level. 22 is below sea level. So 78 minus a negative, this is the same thing as adding, right? So it's 78 plus 22, the absolute value of that. 78 plus 22 is 100. The absolute value of 100 is 100. So the distance from the bottom of the school to the top of the school is 100 feet. But why use the absolute value symbols? The absolute value of 100 is 100, so what does it matter? Well, let's take a look at this one. Mr. Chow found a treasure map that led to the basement of KAS. He begins digging 22 feet below sea level and digs 25 more feet before he realizes that there is, in fact, no treasure. What a silly person to have dug that far. So if we start out at -22 and we dig 25 more feet, that's an addition, right? Because we went further on the number line. And we went further how much? Another 25 feet below sea level, right? So what is that? Well, -22 plus -25 is -47. So the distance was 47 feet, right? But we can't say that a distance is a negative value, so we use an absolute value, 47. This absolute value just helps us to represent this real-life situation of distance. That's it. Thanks. Bye.